Welcome to the community of
engineers, the change agents in the society. We will continue with the topic of wind energy. We have already covered in this topic the wind drivers, how wind is generated, enormous advantages of wind energy, few environmental concerns related to the wind turbines, working principles of wind turbines, main types of wind turbines, various design parameters for the wind turbine siting considerations. In this session, we will discuss the derivation for the expression of wind power. Now, as we know, as energy is the work done, E is equal to W, which is displacing an object by force F to a distance S. So we can write this expression as E is equal to Fs. Now, according to the Newton's law, F is equal to ma. So we can write this expression as E is equal to ma s. Now let's say this is our equation 1. Now considering third equation of motion, which is 2as is equal to v square minus u square. Now here v is the final velocity and u is the initial velocity, or we can write this expression as a is equal to v square minus u square upon 2s. Now let's say, since initial velocity of the object is 0, which is u is equal to 0. So we can write this expression as a is equal to half v square on s. Now let's say this is our equation 2. Now by substituting the value of a by the value of A in equation 1, we have E is equal to m of V square over S into S. So we have E is equal to half mv square, and let's say this is our equation 3, whereas we know whereas wind power is the rate of change of energy, which is P is equal to dE upon dt. So using this expression we can write this half v square dm over dt. Here we know that dm over dt is the mass flow rate, which is equal to rho a dx over dt. Also the rate of change of distance, also the rate of change of distance is velocity. So dm over dt is equal to rho a v, or let's say this is our equation 5. Now by substituting the value of this mass flow rate, by substituting the value in equation 4, we have P is equal to half V square rho a V, or we can write this final expression, that is wind power is equal to half rho a V cube. Now this is the final expression of the wind power. Here we can see the wind power is directly proportional to the cube of the wind velocity. Wind power is directly proportional to the density of the air, and wind power is directly proportional to the swept area of the rotor of the turbine. Now with this we end our discussion here.